An exact value for part A, tangent of cosine inverse -5/13, and part B, sine inverse of tangent 13 pi over 3. Okay, so let's do part A first, right? Part A, let's copy that a problem. We have tangent of cosine inverse. And then inside the value, it would be -5/13. And then we're closing two layers of it, right? So first thing first, let's handle the inside layer first, right? Let's call it like an angle, right? Theta to be the inside. So we go cosine inverse of -5/13. And if we switch it, right, like for inverse, if we inverse it inside out, we're going to get cosine of theta equals to the value of -5/13. All right, so if you remember it, for cosine, cosine inverse, right? They would exist in the quadrant 1 and quadrant 2, going from 0 to pi or 0 to 180 degrees. Okay, so this one is a negative number for cosine, so we know that it's going to live in quadrant 2, right? Because cosine is only in quadrant 1 if it's positive, and quadrant 2 if it's negative. Okay, no other options. So to draw a triangle in quadrant 2 in a unit circle, we're going to draw it like this. This is toward the origin, right, of the circle, and then we're going to have a right angle in here. So then this one is our angle at the origin, and cosine is equals to opposite, or cosine SOHCAHTOA. So cosine is actually ka, so adjacent, divided by hypotenuse. So that means that in this picture, right, the adjacent to it, it would equal to -5, and the hypotenuse, it would be 13. And we're missing opposite. Let me put it in green. We're missing the opposite sign. So how do we catch up with that, right? So we're going to set up the formula, the Pythagorean theorem for this. We go O squared for opposite square plus A squared for adjacent square equals to hypotenuse square, or H squared. Okay, O, we're missing O, so let's just keep it as O squared. And then plus the A in here is -5 square. And the hypotenuse in here would be 13 square. Okay, so fast forward, we're going to square everything, right? And then we're going to minus whatever we have for -5 onto the other side. So fast forward, we're going to get O squared equals to 144. And that means O, to get it, right, we're going to take the square root of both sides in here. So square root in here and square root in here. And the O in here, it would be plus or minus 12. We have two options on it, right? So I'm going to tell you guys how we know which one is like positive or negative in a second. And you can also like sheet up it a little bit in here, right? If this one, the bottom, the base in here of the triangle, if this one you consider it as an x-axis, then this one in here, we will see that for this triangle, it's on top of the x-axis, which means it's on the positive side of the y-axis, right? So the O in here, the opposite in here, it should have a positive value, right? It should have a positive value. So let me get rid of the notes in here, and then it should have a positive value. And then when you go back to it, you can just erase the two options and stick with the positive options, okay? And then the question, getting back to the question, so they asked for tangent. They're asking us for tangent. Let me put it in purple. So tangent, right? If the red one is theta, right? So tangent of theta. SOHCAHTOA, tangent is TOA, which is opposite divided by hypotenuse. I mean, opposite divided by adjacent, TOA, right? So back into the triangle, we'll see that the opposite, it equals to the positive 12 that we just found. And the adjacent is given from the problem. So adjacent in here would be a -5. So the final answer, it would be -12/5. And that's it for part A, right? Just use the definition of SOHCAHTOA for the given, functions, and then you get to the right place, okay? And for part B, first of all, the problem is asking for sine inverse. And then for the inside layer, we have tangent of 13 pi over 3. So same thing, right? Let's talk about the inside layers first, right? So tangent of 13 pi over 3. If you want to, you can get an estimation of what this angle is in degrees. So 13 pi over 3, I'm thinking it equals to 780 degrees. So definitely it's more than one circle, right? So if you keep minusing it out from 360, right? This one, 780 degrees minus by 360 to get the angle smaller, to be on the same spot, but you know, through different circles. The first layer, it would get down to 420, right? But it's still bigger than one circle, so you have to keep doing it, right? So if you still minus it out to 360, you're gonna get 60. Okay, so this one, it has the same tangent value as 60 degrees. Okay, and at this step in here, if you use a unit circle, you're gonna get the x and y value or the cosine psi value of the angle 60, and then tangent is sine divided by cosine. Or if you want to, you can put tangent of 60 degrees into the calculator. Make sure that your calculator is in degree mode, and then you will have it equal to square root of 3. Okay, so this is the inside function, right? Or if you want to, you can get like an approximation of what it is in exact value, and it would be equal to 1.7321 for rounding off. Okay, so now the outside function, let me do it in purple again. So they're asking for sine inverse of that value of 1.7321, right? Which means that, well, if we assign it to an angle theta, right, then we can switch it around. So then we know the sine of theta equals to 1.7321. Okay, ask yourself, psi of what angle equals to 1.7321? The answer is none, right? Because if you think about it, the range of sine and cosine, the value of it has to be between -1 and 1. And 1.7321 is already bigger than 1, right? So there's no angle that has the sine value equals to this much, okay? So the answer in here would be D and E. And the explanation is because 1.732 is bigger than the range of sine or cosine, which is 1. Okay, so this is the final answer.